Yep, as Billy said, this code is going to be it's very verbose. It's going to need a lot of different. You're going to need a new line for every single, you know, JSON property you have. And that may not sound so bad doing this Facebook user, and in some instances, this would be the preferred way to go. But Facebook has a lot of endpoints, as we can see in this next slide here. Each of these endpoints has their own custom data structure, and most of the time, pretty much all of the time, these are all going to be of simple types. So we're going to end up repeating a lot of code in a lot of different places. It's going to be difficult to update this if we end up changing the way we serialize or something like that. And it's going to end up being very difficult to manage doing serialization for all these in a decentralized way. So then the question becomes, how do we centralize our code and make sure we're repeating ourselves as little as possible? And so here we can see the example of serialization with reflection. This one method would be able to work for all of these objects, give or take. This doesn't support nesting and that kind of thing yet, but it could be expanded to support more advanced features in JSON and that kind of thing. But basically, all we see here is we reflectively get the properties of the type. We see if the JSON contains that property, and if we can write to that property on the object here. We go ahead and convert that into the proper type using the type converter and type descriptor features from .NET, and then we just set the value. The reflective parts of this are primarily the get properties and the set value we see down there at the bottom. These are the kind of the crux of what makes this code work, in that we can take these properties out and iterate over them like a list. If we weren't able to do that, we would have to, as you saw before, one by one hard code all of these things and assign them manually. And then over there on the bottom right, we can see an example of calling this. We just instantiate a new person and then call it a serialized object with the JSON and a reference to that object. And we have our object with our populated fields from the JSON. Simple as that. But this also is not necessarily as generic as it could be. And that's where we get into attributes. Attributes are a way of attaching additional metadata to a property, field, or class. So what that means is that we can define specialized classes, and we can use these classes as tags to say this method, this field, this class has this certain information attached to it. I'll give you an example here using F# from earlier in the semester. Remember this little weird thing here we had to put on our main functions? That was an attribute that said to the interpreter, it said this is the starting point of the program. These attributes are a common feature of .NET languages, and we're going to see now what that looks like in C#. So here we have implementing our own attribute in C#. On the left there, we see that we just declare a simple class with a couple properties, and we just inherit from system.attribute. We mark it with its own attribute that tells it that it can do attribute targets.all, which means it can go on methods, properties, classes, whatever it can be put on it. And we have a default constructor that just initializes some defaults there for us. Then over here, we're going to modify our Facebook user class. We're now, for first name, we've changed it now. The first name does not match the name from the JSON because we want to use camel case, they use Pascal case. So we give it the serializer settings, give it a name. We say the name for the serializer is first underscore name, even though our class name is first name with no underscore. So we can then use that from the serializer to be able to get that and serialize it properly, even though the name mismatch. Then down here we have an extra field we put on there. We has hands. I don't know what that means, but it's an extra field we have there. And we've set it to skip equals true. That means we should not try to serialize it because there's nothing there to serialize. Now, by default, the serializer we had up there would also do that, but this is a good thing in case you can also add this to fields that may be in the JSON but might be a bit too complex, or you might want to do them in a custom way. You can do that as well. So then we can see how we would use these back in our deserialized object. Over here, we see the line being pointed out. That code grabs the first instance of the settings class that is attached to that object, to that property. So if we see here, we're attaching these serializer settings to the each property that they precede. So the serializer setting name equals first name is attached to first name. This skip equals true one is attached to has hands. So then we can pull that up here, get the first instance of the class, and we suddenly have this serializing settings class that has all these properties that we set. So we can then inspect that and see how we should handle it differently based on what the programmer of the class has indicated to us how he wants it handled. We also, over here, we set some defaults just in case there is no setting set. So we've added in here, we want to make sure we're not trying to serialize anything that's marked as settings.skip. And we're also null concatenating the settings.name with the property name. So that just basically means if the settings name is null, then it uses the property name. But if the settings name is not null, it'll use that name. So in the case of our first name, the name is not null. So instead of using the property name, it'll use that special name we gave it. And this gives us a lot more flexibility with using our reflective code here, and is one of the core supporting features for using the reflection in this manner. So moving right along, what are the drawbacks of reflection? Well, reflection can break some patterns that you may come to expect and can make debugging much more difficult because it is a very unconventional way of accessing everything. So for example, if a method name changes, if the property name changes and you have it hard-coded somewhere, but reflectively, so you're accessing it via a string, or you're pulling it out via just its name comparing to a different string, you'll have issues there because it'll break that code, but you won't get compiler warnings about it. That's one place where you probably should not be using reflection. If you know what your names of these properties are and that kind of thing, you probably should be using some kind of inheritance or interface implementation, that kind of thing. That brings us to our next point, which is the Band-Aid approach. This is very easy to use if you have some very large and difficult to maneuver object model. But if you're using this, like I said, where you know the name you want to call, but just you can't use polymorphism because your object inheritance tree is broken, and you want to change all these things, implement a new interface, etc., etc. This is a Band-Aid approach to try to fix this fundamentally broken object model. So those kind of problems you could apply reflection to, but most of the time you're probably going to want to look at other areas of your code to fix those first. This also loses some advantage of pre-compiled type safety. So because the compiler doesn't know exactly what properties you're going to be accessing before you do, you could end up with type conversion errors and that kind of thing that'll sneak up on you on runtime that you would have gotten if you had just used regular hard-coded accesses and that kind of thing. So yeah, that's our presentation. Hope you enjoyed it.